All right, how's everybody doing today? Hopefully you guys are doing well, staying healthy, social distancing. Today we're going to continue on with our unit of solving quadratics. This is where we find the roots of a quadratic, or the x-intercept, or sometimes also called the zeros. Now this first example is what we primarily did last week. I believe we did this on Wednesday and Thursday, and you can check out the videos from last week if you want to see some more examples of problems like this. We focused on trinomials and actually finding where they're going to equal 0. So what we did to solve these is we factored them like we did in our last unit. The way that we factor, remember, is we make our little x off to the side here. We put our last number up top, which is negative 15, our middle coefficient down at the bottom, which is 2, and we're looking for two numbers that multiply to negative 15, but at the same time add to 2. In this case, that would be positive 5 and negative 3. And so this is going to be x plus 5, x minus 3, is equal to 0. And then we're going to solve that. Now the way that we solve that is we are going to set each of these equal to 0. So we're going to have x plus 5 is equal to 0, and also x minus 3 is equal to 0. And this is obviously pretty easy equations for you guys to solve. We're simply going to subtract 5 on both sides, and I get x equals negative 5. And here I'm going to add 3 on both sides, and I'm going to get x equals 3. So that is my root, or my x-intercept, to this particular quadratic. Now what I mean by that, and I know I'm throwing these vocabulary words out a lot here, is if you were to look in your calculator and actually graph this, you would have a quadratic function, so it's going to be a parabola, and it's going to cross the x-axis here at negative 5 and 3. So I haven't graphed this exactly, but my guess is you're going to get something that looks like this. And this point right here is going to be negative 5, and this point right here is 3. These 2 points is what we're finding with this answer. So we're finding where this crosses the x-axis. All right, now for today, we're going to move a little bit past the trinomial, and we're going to look at the second thing that we did, which is a difference of perfect squares. So you'll recall from our unit on factoring that we had things like x squared minus 49. So if we were going to factor this, this would factor as x plus 7, x minus 7. Remember, we take the square root of x squared, that's x and x. The square root of 49 is 7 and 7. And we want one to be positive and one to be negative. Now, the only difference today is instead of just doing that, we're going to set this equal to 0. So now what we have to do is we have to take these two and we have to solve them. So we're going to take our x plus 7, and we're going to set that equal to 0. And we're going to take our x minus 7, and we're going to set that equal to 0. So I can easily solve that by subtracting 7 on both sides. This gives me x equals negative 7. And this side over here is going to give me x equals 7. So this particular quadratic is going to have two roots again, one at negative 7 and one at positive 7. All right, we're going to do one final example that's a little bit trickier. Something like this, 4x squared minus 81. Now, if I look at this, you should see that I do still have a difference of perfect squares. 4, I can take the square root of. X squared, I can take the square root of. 81, I can take the square root of. And there's a difference. So I'm going to go ahead and factor that just like I would in our last unit. know that that's going to equal 0. Our square root of 4 is 2. Our square root of x squared is our x. Now it's a difference of perfect squares, so we're going to have a positive and a negative. And then we're going to do the square root of 81. 9 and 9. So now to finish solving this, which we didn't have to do the last time, I'm going to set each of these equal to 0. It's a little bit of a tougher equation, but definitely one that we can handle. 2x plus 9 equals 0, and 2x minus 9 is equal to 0. So to solve, this is a two-step equation. I'm going to subtract 9 on both sides. I'm going to get 2x is equal to negative 9. I'm going to divide by 2. And I'm going to get x equals a negative 9 halves. That's going to be one of my roots. Now on the other side here, I'm going to add 9 to both sides. So I'm going to have 2x is equal to 9. I'm going to divide by 2. And I'm going to get x equals 9 halves, this time positive 9 halves. Now, you'll notice that we ended up with a fraction here, or if we were to divide it, we'd get decimal, negative 4.5, positive 4.5. That's because a lot of times our parabola isn't going to cross the x-axis at a perfect number. It's possible for us to get decimals or fractions, and a lot of times that's going to be our more likely scenario. All right. Hopefully this lesson was informative to you and you guys sort of get it. If not, definitely shoot me a message and I can do some more examples for you. But hopefully this helped, and I will have another video ready for you guys tomorrow. Take care.